right, in this video we're going to talk about, we're kind of coming off of proportions, and we're going to talk about when we have equations where we have variables in the denominator. So variables in the bottom of a fraction. So let's look at a couple examples here. All right, let's look at the first example here. Remember, all of our equation rules, they all apply here. So just like before, I want to get my x by itself. So we have to get rid of the 6 and we have to get rid of the -4 from the left-hand side. And just like before, whoever is attached to the x, you're not going to get rid of him first. You're going to get rid of the other number. So I'm going to go ahead and I'm going to get rid of my 4 in my first problem here. I'm going to add him to both sides. So I'm left with 6 over x equals -6. Now, this is kind of the weird part. I need to get the x by itself, but before I get him by itself, I have to get him out of the denominator. So I'm going to move, and I'm going to multiply both sides by x. When I do that, on the left-hand side, just like if it was a number, they eliminate. And I'm left with 6 is equal to -6x. And so you can see where we're going here. I'm going to divide both sides by -6. And that's going to give me x is equal to -1. Okay, let's look at the next problem here. Now I have some fractions with some numbers. So the first thing that it looks like to me is it looks like I have a 1/3 outside of, the number that's attached to my variable. So I'm going to go ahead and just like if it was a regular integer number, I'm going to go ahead and I'm going to subtract them. And don't be nervous whenever you see, numbers that are fractions, because you just treat them exactly like integers. So if we do this, you can see that they're going to cancel out, and I'm going to be left with 3 over x is equal to 1/3. All right, now I need to get rid of my x variable. Like I did before, I'm going to go ahead and multiply the left and the right side by my x. On the left-hand side, he's going to eliminate and leave me with 3. And on the other side, you can see that I have, I've got to multiply by x. So really I have x divided by 3, right? Because up here, if I have him over 1, if I were to multiply them, I would have 1 times x is x, and 3 times 1 is 3. And you know where we're going with this? We're going to go ahead and get rid of our 3 by multiplying. And we have 9 is equal to x. So x equals 9 is our final answer. And you can always go ahead and you can substitute that number back into the equation to double check your answer. All right, let's look at some more challenging ones. All right, the next problem here, you notice that I have 2x and I have x in the denominator. And I'm adding fractions. So back at the very beginning of Unit 1, we talked about, adding fractions. And it's kind of one of those things that you did a lot of in years prior to algebra. So when you think about adding fractions, you probably think of creating a common denominator. Well, the same thing works here. So here I have 2 fractions, and I need to make a common denominator. My common denominator that I'm going to make is going to be 2x. So you can see in my first fraction, I already have a 2x, so I'm going to leave my numerator as a 5. But in my second fraction, I actually need to, I want to get 2x in the bottom, I multiplied it by 2. So I also have to multiply the numerator by 2, and that's going to give me 8. So you can kind of see where I'm going with this. That is all equal to 13. Well, now I'm going to go ahead and add those 2 fractions together. When I add them together, it's going to give me 13 over 2x is equal to 13. And then from there, I'm going to go ahead and do that same technique. I'm going to multiply the left by 2x and the right by 2x. And the reason why I did that, because it gets it out of the denominator now. And that's what I want. And I'm going to finish it off by dividing both sides by 26. And my variable is going to equal 1/2. So the number 1/2 is the number that I would substitute into the x here and the x here to make the left side equal to the right side. So you don't want to sit and try to guess what that number is, because it's probably going to take you a long time. There's always a systematic way of solving it. All right, let's look at the next one. Okay, now this is kind of unique because not only do we have 2x and we have 5x, but they're on different sides of the equal sign. So my first kind of reaction is to get them both on the same side. So I'm going to go ahead and I'm just going to take a second and I'm going to move my 1 over 2x to the other side. Now, you may have wanted to move 1 over 5x to the left and 3/10 to the right, and that's perfectly fine as well. But I decided to approach it this way, but either one is perfectly fine. Okay, so I'm going to have 3 over 10 is equal to, now you can see that I'm just going to rewrite it like this, 1 over 5x minus 1 over 2x. You can see that I'm subtracting two fractions, and so when you subtract two fractions, you have to make yourself a common denominator. So I'm going to make my common denominator as 10x. To get to 10x, I had to multiply 5x by 2, so I also have to go ahead and multiply the top by 2 as well. And to get 2x to 10x, I have to multiply it by 5. So I'm going to go ahead and do that as well. So I'm going to go ahead and simplify my fractions just like as if I were subtracting fractions. It works the same way. I'm going to get negative 3 over 10x. All right. To finish this off, I'm going to do that little technique to get my x out of the denominator. And I'm going to multiply my 10x on both sides. That gets out of the denominator. So I'm left with, I'm going to multiply my 10x times 3, which is going to give me 30x over 10. That's equal to negative 3. And I can go ahead and I can actually simplify that down to 3x is negative 3. And then I can divide it by 3. So x is going to be negative 1. And that is how you solve equations with variables in the denominator. The goal is always to get it out of the denominator.